Welcome to this AI Wisdom series that we are actually having as part of the Applied AI Research Center in Macquarie University. So this is going to be the very first one, and which is more like a kind of kickoff of this webinar series. And we are planning some more, maybe one or two on monthly basis. And the main goal of this series is to just, I would say, focus on what's actually happening in the world of AI and trying to just cover those key domains that we think people in academia and industry should be across. So for today's session, as you can see, we are planning to cover some of these latest updates and the state of AI, specifically in infrastructure, governance, and also the things that are happening in research and education. So my name is Sam, and I'm an adjunct fellow with Macquarie University, and also I'm leading the sales of accelerated compute in Amazon Web Services. Today, I'm also joined by Professor Amin Beheshti. Amin, do you want to do a quick intro and then we can kick it off?
Yeah, sure. Thanks very much, Sam. Hi, everyone. Thank you so much for joining this session. I think this is a great initiative by Sam, led by Center for Applied AI, to provide AI literacy and help general public understand what are the new innovations and technologies in the world of artificial intelligence. And my name is Amin Beheshti. I'm a full professor of data science and director for the Center for Applied AI at Macquarie University, Sydney, Australia. And again, thanks, Sam, for initiating this great idea.
Awesome. Thanks, Amin. Yeah, I think for the purpose of today, so Amin is going to start with the presentation, and then I will just maybe 15 to 20 minutes. Amin is going to cover some of his content, and then I will just also cover some of these domains around AI infrastructure and governance. Yeah, so I'm just going to stop sharing, and Amin, if you want, you can just start your screen sharing.
Sure. So do you see my screen now?
Yeah, all good.
Okay, wonderful. So again, welcome to this session. I'll just briefly introduce you to the Center for Applied AI. The Center for Applied AI established the Big Data Society back in 2018. Now over 4,500 members, organizing big workshops and hackathons with high-tech companies, including AWS. The center also initiated the Data Science Lab, one of the biggest research labs in Southern Hemisphere. We secured over 120 industry-based scholarships, and we have over 50 alumni, over 70 HDR students at the moment. Our graduates now, they are leading top positions, like, for example, staff AI scientist at Google, or lead scientist at Microsoft, head of AI at Optus. And this shows, the creativity and the innovation in the center and in the lab. The center itself secured over 44 million over the last 5-6 years with high-tech companies and organizations in Australia, government agencies. And, the good thing about the center, it is an applied focus. So, we help organizations understand their big data, use it in a smart way, and then solve real-world problems. Just to quickly recap what has been happening. So this figure shows you few innovations that we have had in the past few decades. If you see, it started, gradually, and then after 2022, the number of innovations, growing up suddenly. Just to summarize this figure, from 1900 to 2000, we had 100 years worth of innovation. So, we had around 10, 20, very impressive innovations. From 2000 to 2022, we had a mature level of technology. Computer science, helped, all these technologies helped the automation. And then in 22 years' time, we had a worth of 100 years of innovation. And then from 2022, where we had, this generative AI came into, the real world applications. And before that, everything was scientific fictional. OpenAI showed that, okay, these technologies could be real. There could be a system that, understand our language, interact with us much, much better than a human. And then it started to changing the business model, revolutionizing, how we complete some sort of a processes. So this is what we are going to cover. And this is a nutshell evolution of AI. It started, from the foundation theories, focusing on algorithms. Then software engineering, contributed a lot. And then around 1970s, everyone, was disappointed with AI because we really didn't have, enough data and, technology and, compute and scale to turn all this theory into something that is really working. But then suddenly, we had the technologies to capture data, and then we had the big data technologies capturing information scattered over different systems, and helped us, having the AI version that we have today. So few things contributed: software engineering, data, and then big data and scale. From the software engineering point of view, we started from spaghetti code to structured programming to modular programming to object-oriented programming to service-oriented computing to natural language-oriented programming. And over the times, all these software engineering technologies, help us to focus on reusability, on abstraction, on scalability, and then now today we can just use natural language to generate programs, or even we very soon get to the point that using natural language we can generate very complex systems. So we have a very interesting paper. I cited it in these slides. If you are interested in natural language oriented programming, you can have a look at that paper as well. Traditionally, software engineering, if you look at a computer from a black box point of view, consider a computer as a CPU and RAM. We had two inputs, data and program, and then we generate the output. For example, you have a program that gets two numbers from the input, generate the summation, and then using CPU and RAM, we generate the output. So this is a traditional software engineering. But what has happened in the last 2 decades, a new technology called machine learning started, to complement software engineering with a big difference. So here, you have the same computer, same resources, CPU and RAM, but you really don't have any program. You just need to have the data as an input and some examples of the output. For example, you want to develop a model that identify face, from some sort of images. You have thousands and thousands of images as an input data, and then some examples of identified face as the output. And the computer, was trained, to generate a program that is able to do that. So what if you were able to connect the program to the traditional software engineering? And then now you have a program that is able to identify, for example, a face, from an image, or for example, activity or action from text, whatever model, we are going to develop. So this is what, we called machine learning engineering. And it was really interesting in the last decade. There has been a huge number of software engineers, upskilled to be machine learning engineer. And now today, we have a generative AI. So you really don't need to have the data. You really don't need to have the program or the output. You only need to have a high level understanding of the problem. And then same computer not only generate the data for you, but also generate the program. I'm sure many of you have been using, for example, ChatGPT, Copilot, or, similar technologies to generate, some sort of programs in any specific programming language that you are interested. From the data point of view, this is also contributed a lot in artificial intelligence. So that today, it is estimated that each day we generate over 181 zettabyte of data. So huge amount of information generated on social media, open data, private data, and more. And we are really lucky, to have technologies to be able to capture this huge amount of information today. Big data has been the next big data engine for AI models. So big data is really different from a large data set. So large data set, you focus on one specific data island. But if you think about scenarios, for example, like police investigation, we need to capture and ingest data from different sources, from social data, from open data, from IoT data. There are historical police data, for example, in this scenario. So you see there are data generated on different platforms, with different syntax and semantics and different standards. They are heterogeneous. And the capability to connect all these, link all these information would help us generating a different sort of insight compared to the time that you focus only one island of data. This is another example of a big data in health, for example, in cancer detection and prediction. So the more you identify different islands of data, the better outcome you can have. So, you can collect data, from the business data islands, for example, from the pharmacies, from the financial data. There are lots of IoT devices, collecting information from patients. There are lots of researchers focusing on medical and clinical data. Social data islands, there are forums, for example, that cancer patients exchange knowledge and share best practices. So you see different sources of data, and the first step would be to identify relevant data sources here. So big data did a really big help in the success of AI. So I also had delivered an open lecture with more details of these technologies. If you are interested, you can have a look at the open lecture. It's available online as well. But let's start understanding what is AI before Sam goes into more technical aspects of the technology. It's really important to understand what is artificial intelligence, because there are different definitions of AI available today. If we want to really understand what is artificial intelligence, we need to start from intelligence. So as humans, we have a gift, we have intelligence, and this is the capability to acquire and apply knowledge and skills in order to accomplish a process. There are few very important keywords in this definition. The first one is process. Process is a set of related tasks and activities to achieve a specific goal. And if you think about it, whatever we do is a set of processes. For example, you wake up in the morning, the first thing that you do, you make up your bed. So there's a process to do that. It means that, you need to start. Then there are some related tasks and activities that you need to follow to complete the task and process that you are doing. And there's a goal behind that. You want to change your phone number, you want to enroll in a unit, you want to apply for a job, you are a police investigator, you want to start an investigation. So whatever you want to do is a process. One of the interesting definition of intelligence that I also like is the ability to adapt to change. So even adapting to change is a process. That's why this definition will cover almost all other definitions for intelligence. Knowledge and skill is very important. So knowledge is something that you can learn, but specifically with a natural language. For example, when we have a newborn kid, we first start teaching them to speak and understand a specific language. So then we are ready to transfer the knowledge. And a skill is also very important. A skill, this is where we have subject matter experts in the field, and then we want to train, for example, these kids on the skill set that we have. So this skill set could be in different domains, from medicine to law to engineering. And again, going back to the definition of intelligence, this is the capability to acquire and apply all those knowledge and skills, in order to complete a process. Okay, so we have different types of intelligence. I just want to highlight three important ones here. The first one is analytical intelligence. So analytical intelligence is where, for example, we focus on the knowledge, we have an abstract language to communicate, and then we are ready to identify the main entities around us or understand concepts, whatever it is. So for example, when we have a newborn baby sent into kindergarten, they will start, identifying colors. They will start, for example, identifying the entities around them. And then over time, they develop their analytical intelligence. So this will be done by the end of primary school normally. So the goal of the primary school is to transfer this knowledge to next generation. And we are lucky, to have the analytical intelligence to be able to understand that. The other type of intelligence is cognitive intelligence. You can connect it, to applied applications or applied intelligence as well. From the education point of view, in high schools and undergrad courses in universities, we engage with subject matter experts, and then we try to train our next generation on a specific domain. For example, someone wants to be an engineer, someone wants to be a lawyer, someone wants to be a medical doctor. So the cognitive intelligence help us to learn from experience, learn from observation, and then learn from subject matter experts in the field. And then the interesting part of the intelligence is generative intelligence. So, this is related specifically to that capability keyword that we had in the definition of the intelligence. Generative intelligence enable us to create something new, create us in ideation, in problem solving, in critical thinking. If you remember, the first slide that I showed you, and it was a number of innovations there. So it is mainly coming from generative intelligence. But if we want to have a good generative intelligence engine, we need to have a good analytical and cognitive intelligence to build the generative on top of that. And from education point of view, we have research degrees in universities that specifically focus on reasoning, problem solving, and critical thinking. So this is a very good way to develop the generative intelligence for us. And now it is time to define what is AI, or artificial intelligence. If we go back, to the previous slide where we had the generative intelligence, and I highlighted that, most of those innovations, that we have is the result of generative intelligence. We get to the point that we were able to generate an artificial version of our own intelligence. And this is really interesting. So, we have the intelligence, we develop analytical, cognitive, generative over time. But what is also really important here is a process called collective learning. So collective learning is a process that is very specific to human. And this is where we transfer the knowledge to next generation. So animals, they cannot do that because in 100 years time, they will be the same, right? But we are able to transfer the knowledge to next generation, and next generation will build on top of that. So this is how we innovate. Just think about, all the advancement that happened in computer science in the last 3-4 decades. So, there has been some innovation, and then people start building on top of that. If you have heard about, for example, open source technologies, the main idea was to share the knowledge available to next generation, and then they build on top of that. So that was a very important contribution to collective learning. So again, we get to the point where we were able to generate the artificial version of our own intelligence. What does it mean? So intelligence was the capability to acquire and apply knowledge and skills to accomplish a process. Now, if we have an artificial version of that, there could be a system or an algorithm or machine that is capable to doing the same thing. So it is capable to learn the knowledge, it is capable to learn the skill, and it is capable to use that to accomplish a process. And that's where it brings value to businesses. Because, we have different types of processes. It can be personal process, it can be business process. Think about a bank, for example, where you are going to apply for a loan. There are different process models only specifically for applying for the loan, right? So depends on your international or local student, how old are you, what sort of job you have, you will be mapped to a different process model. And then artificial intelligence is able, to follow those processes, is able to automate those processes, is able to augment those processes. Augmentation is very important. So augmentation is when we have people working in companies, and then we can help them to do the process better, more accurate. So AI, can augment them with this capability. And also improvement is a very important step. Just comparing to intelligence, we have different types of AI, but again, the top three is analytical AI. So analytical AI focus on data. You have a data, you want to understand it. It can be text, it can be image. Over 80% of the advancement that we have seen so far has been focusing on analytical AI, mining, rating, ranking. And as I mentioned, the main research problem that we have in analytical AI is understanding the data. We have cognitive AI, any AI system that can help us in decision making and choosing the best next step. And we have generative AI, any AI system that can generate something new. For example, it can generate a new text, it can generate new image, it can generate, for example, new programming code like GitHub Copilot. It can generate a new process. For example, in our center, we have a technology called Process GPT that is designed to generate new process models and process instances. The other important aspect is the learning part. So if we go back to human and then intelligence, learning is located in different types of intelligence that we have. That's why, we have supervised learning, we have semi-supervised learning, we have unsupervised learning, we have reinforcement learning. So these are the things that, we have in our community as human. So for example, when you are in primary school, you are under a very specific supervised learning, to make sure that, you follow all those steps and you train, based on the data that, we fed into you. And then, we have semi-supervised, you go to high school and then they will send you to camp. So it's a minimal supervision, but, they let you to learn from errors, mistakes, and experience. Similar to unsupervised and reinforcement learning. Just compare it, to artificial intelligence. Learning is in different part of analytical, cognitive, and generative intelligence. We have supervised, we have unsupervised, we have semi-supervised, we have reinforcement learning. Supervised is where you have lots of sample data to train your model, and unsupervised, this is where you don't have any sample data. And then there are different things in the middle, and reinforcement learning is very critical. So for example, we tell the model that you are doing right or wrong by, for example, giving some sort of a award or punishment. Just to put everything into one summary slide, and then after that, I will get Sam to discuss more about the technical side. So we start from the intelligence. We discussed that we have different type of intelligence, and then we use the intelligence, to accomplish different processes. Processes could be personal or business. And then we get to the point that we were able to generate the artificial version of our own intelligence. We have analytical intelligence focusing on the data, cognitive intelligence focusing on the decision, and generative intelligence focusing on the creation. And then, this AI is in the digital world. But what if, we are able to give it access to the physical world that we are living? So, we can get the AI model see us. So for example, we have vision computing, it can hear us, it can sense. So whatever technology that we can give to this digital version of the AI, then they can come to our real world, and then there would be lots of interesting applications. You have heard about, for example, humanoid AI. And then this is where, this is the value that most of the organizations are quite interested in. So how we can use this technology, artificial intelligence, to automate processes, to augment processes, and to improve processes. And this is where the value comes in. Another important thing to consider, is the foundation model. So before foundation models, we had a model developed for one specific tasks. For example, you develop a model, to identify face, for example, from image, or identify, for example, some sort of a patterns in the data. You want to extract activity or action from email, whatever it is. And then the best we could do, we could have a library of, these models that could focus on different tasks. Still, you need to have lots of data to train these information. But back in 2020, 2021, scientists in Stanford introduced a new model, foundation model, that focus on unstructured, unsupervised data. They could scale, they could generalize, they can focus on different types of tasks at the same time. For example, ChatGPT is a foundation model over text, DALL-E is a foundation model over image, GitHub Copilot is a foundation model over programming code. We have very interesting projects in the center: foundation model for biology, foundation model for education. And then because the foundation model supports transfer learning, it is trained over some sort of a data, unstructured, unsupervised, you have the opportunity to fine-tune it. So this is where you have some sample data, and then you want to leverage an existing foundation model, for example, a large language model. and then fine tune it based on some sort of a domain specific data that you have. If you don't have data, don't worry. You can follow prompting. So prompting is where you use reinforcement learning with human feedback or reinforcement learning with AI feedback to mimic the knowledge of subject matter expert, and then use that to tune your model. So just to summarize, generative AI is very high level topic. Foundation model sits under that, and large language model is a foundation model over natural language text. Before giving this to Sam, so one last thing that I want to discuss is the AGI, artificial general intelligence, and it's also important to understand this concept. So you remember we discussed about collective learning, a process that helps us transfer knowledge across generations. And think about the technology that we have today is able to capture all the knowledge and skills that our ancestors passed on over time, and we all add something on top of that. Let's call this general intelligence. So general intelligence include most of the knowledge that we have in different domains, for example, from law, from engineering, from medicine. So just think about different domains that we have. Then if we are able to augment an intelligent entity with this general intelligence, this is what we can call artificial general intelligence. This intelligent entity could be an AI model. It can be a human. So we can think sci-fi, and for example, there could be, a time where, for example, similar to the project that Elon Musk has, Neuralink, we would be able, to connect our brain, to general intelligence. So this way, let's say when I want to make a decision, I have access to different domains. For example, I know cognitive science, I know social science, I know data science, I know law, I know business, and then now the decision that I make is next level. So it's not creative, it's creative to the power of creative. So augmenting any entity using general intelligence, which we can call AGI, will generate a new type of intelligence that we can call super intelligence, and this is creativity to the power of creativity. And then the last one is responsibility. So AI for good is a very important concept. And, for example, we discussed about the definition of intelligence. We discussed that there are few important keywords like knowledge, skill, and creativity there. Think about creativity. So if we think responsible, we can come up with proper use. For example, you can think about a future where we minimize, the number of disease. For example, we support targeted therapy. We support personalized medicine. And, this is a very good and responsible use of AI. But at the same time, if we have a technology and we use it irresponsible, so any time we have a new technology, there could be misuse. So there could be criminal activities. And then, just look at our society. We have regulations, we have law enforcement, we have offense. For example, if you drink and drive, there is an offense in law enforcement, and, there's a regulation for that. So that's a criminal activity. But think about bad people augmented with AI, so they could easily bypass some of these offenses that we have today. That's why we are going to see the number of offenses, and the regulations will change quite rapidly. These are some examples of irresponsible use of AI, like deep fakes, misinformation, voice cloning, AI fraud, and plagiarism that we should really avoid. So I really hope that this was a good intro to artificial intelligence, and now I pass on to Sam. Thank you so much, Sam. I stop sharing.
Awesome. Thanks, Amin. Good. I would say context and foundation. And okay, so are you able to see my screen?
Yes.
Okay, perfect. So yeah, building on the top of this foundation, so I just prepare 4 main topics. And these are actually I'm just trying to address what is actually the latest in these 4 main topics. And if you check any sort of AI news and updates, these are the key, I would say, theme that we see. And I'm going to cover what's actually happening in these 4 domains. I hope I can just, I have another 28 minutes. I hope I can just cover all of them. All right, let's, let me just see what's happening with, All right. So let's start with the AI infrastructure. So those four topics, AI infrastructure, I'm going to cover small LMs or small language models. And then based on whatever that Amin covered about AGI, I'm going to cover what's actually happening in that aspect, and also AI governance, which is actually like all those rules and policies that we need to have to make sure that AI is actually used responsibly. So with the AI infrastructure, quick context, I think to help you better understand what we mean by saying AI infrastructure. So we have this classic traditional compute system, which are based on CPUs. So I'm sure all of you are familiar. So all these laptops, computers, which has like a CPUs plus a network interface card. So this is more like a kind of, I would say, the foundation of computing. But then with all these new use cases that needs more like a kind of parallel processing, things like AI or machine learning model training and inference, which usually you are dealing with a huge amount of data, and then you need to have parallel processing capabilities. So these traditional compute system is not actually just built for those types of cases. And that's where we have what we call it as accelerated computing, which is actually the foundation of AI infrastructure. So these accelerated computing, it's just built to enable more parallel processing capabilities that we need for what we call it as high performance computing, and AI and ML use cases is just a subset of those computing capabilities. So accelerated computing, there are like three main types of technologies there. So we have GPUs, which I think most of you are familiar from NVIDIA, which is ideal for parallel processing capabilities. And then things that are actually just used with by a lot of companies for AI ML training and inference. We have also FPGA, which is there is some more level of, I would say, flexibility in terms of the way that you can just reprogram the logic of FPGA and then tailor it to like a specific use case, like whether it's like AI ML training or inference. And then we also have the third types of accelerated computing, which what we call it ASICs, which is application specific RCs, which are more like a kind of purpose built for a specific use cases. Let's say if we have like AI training, so those accelerated computing technology are built to be optimized for AI training, or the same for like AI inference. Like as an example, in Amazon, we have AWS Trainium and Inferentia, which are actually just those types of ASICs, AI chips, which are built to train and run AI ML inference. So this is more like a kind of context that you need to know in order to understand what we mean by saying AI infrastructure. So in terms of like the market, what's actually happening right now, so the market for AI infrastructure is expected, and actually like in 2025, we have like nearly 92 billion for this market, which grows like by 30% from 2024. So NVIDIA is actually the dominant for this market, so having like 92% of the market share. And then there are like some emerging companies that are working on those ASICs technology that I mentioned, like Amazon, Google, Apple, that they are trying to have like their own AI chips so that their customers can leverage. So in terms of like the comparison between GPUs and ASICs, so GPUs usually you have like a more flexibility, because GPUs is actually accelerated computing technology which are built for different use cases, whether you want to run AI ML training or whether you want to render or running big data processing. So GPU is there so that there is a lot more flexibility in terms of like the use cases, but at the same time, it needs huge power, and also it provides a lot of better performance. But when it comes to the efficiency, that's the kind of like the key area that GPUs usually lack of capability. So ASICs, those I would say purpose-built technology. So because they are like purpose-built, they usually have less flexibility. But then at the same time, in terms of like the efficiency, they actually just provide a like good level of efficiency. So in terms of GPUs, so if you follow NVIDIA technology, there are like different types of architecture for GPUs. So starting from 2010, so they just slowly add more and more types of generation for their architecture. So I would say the popular one for the case of AI ML are these four types of architecture. So we have architecture like Ampere, Hopper, and Blackwell, which is actually used by a lot of businesses and companies to run their AI ML workload on the top of those technology. So plus those GPUs and ASICs, what we see, we have like new startup types of company like Grok, Sampanova, which are like, they're actually just having their own offering for AI infrastructure. Like as an example, Grok, it's more like a kind of startup that actually just provide the offerings for AI inference. So they have like their own AI chips, which are actually optimized for running AI inference. Or like Sampanova is like another one, which actually just try to provide those accelerated computing solutions, which are good for reconfigurable data flow architecture. So these are like kind of like some of these, I would say, players that they are trying to just get some level of share from the market. So the next topic that I'm going to cover is about the small LLM. So what we see since, I would say, start of this year, we see there is a more, I would say, focus on a smaller language model rather than those big ones. And the main reason is because, usually these large language models, they need a lot of compute power capability, and that's usually expensive. And a lot of companies, especially small and medium-sized companies, they cannot afford it to use those types of large language model. So these small language model is there to actually just provide kind of like more cost-effective solution to run these different types of AI use cases. And we are seeing that actually more and more small language model is actually just in the market, and a lot of, I would say, big players trying to just have their own offering. And this is going to be one of the, I would say, the big disruption that we are seeing in the AI infrastructure, I would say, market, because those small models like the DeepSeek or Free, these are like, they don't, I would say, doesn't need to have huge compute power in order to be used to run those models. And then there is, because there is not so much, I would say, compute power needed for those models, those like a small language model actually just impact the demand that we have in terms of the GPUs. And also as they are more affordable, we can see that those small language model provide more democratized access, so that every enterprises, every like small or medium-sized businesses, they can just leverage to build different AI use cases. And especially the latest one, which is more like an agentic. So those agentic AI use cases is where these small language models actually are going to play a key role, because nearly, I would say, around 80 to 90% of future AI use cases, they are agentic. And those agentic ones, if we can provide the more efficiency and cost effectiveness through these small language model, they actually just can grow dramatically. And that's the kind of like the big, I would say, push that we're seeing, so that those agentic AI use cases, they're going to leverage more small language model. And then that small language model enable more, I would say, sustainable scale and growth of AI infrastructure, because when they are efficient, so you can just leverage those for more AI use cases. Plus those small model, like there are like some other strategies to make sure like the AI infrastructure and the future of AI infrastructure are more sustainable. And these are also the areas that we see a lot of investment that's happening. So like those big cloud provider and data centers are trying to just leverage more renewable energy. So as you know, like all these AI use cases, they need more compute, which means they need more power. And if we can leverage more renewable, we can make sure that they are more efficient, and also at the same time they are more greener. So renewable energy, small language model, using more greener algorithms to make sure like whatever the model that we are running, they are running in an efficient way. So that can help to make sure like that we have a more, like I would say, sustainable scale of AI infrastructure, which is actually important for future of them, because we want to make sure that whatever that we are developing and also is using, it's in a way that is more, I would say, scalable and also sustainable. So these are like the key areas that we see like a lot of, I would say, focus when it comes to the AI infrastructure. All right. So that was like about the AI infrastructure, what's actually happening in that domain. So the next topic that I'm going to cover is the AGI. I mean, already provide some level of foundation, but then when it comes to the AGI, it's good to understand. So what is actually just for the competitor of the AGI? So we have this concept of narrow AI, which is those AI solutions which are built for a specific task, like image recognition, language translation. So those are like AIs that are domain specific, and you cannot just use those for like different, I would say, use cases or domain. So AGI, on the other hand, it's actually there to provide a solution that can work like a human. So we as a human, like if we have like capabilities that we can just play in different space, different domain, and then we can just put the, I would say, focus and more effort to just be, I would say, specialized in those. So AGI is going to be and going to follow the same path to make sure, like if we have these AGI solution, it's going to be specialized through like a kind of process for like a specific domain, and it can adapt to those new situation if it is needed. So narrow AI versus AGI, this is actually just this comparison, I would say, can help you to understand what we mean by AGI. And there are like different perspectives for AGI definition. So we have like this computer science perspective, which is more around the intelligence that can achieve goals, and it's more focusing more on the problem solving aspect of the AI. Then we have this psychological view, which is actually add another layer. So it focuses more on the adaptability, more like a kind of human intelligence. So in this angle, so AGI, it's not just to solve the problem, but also learn from experience and also adjust it to unfamiliar situation. And then we also have this philosophical debate as well around AGI, which is more around AGI to replicate human cognition as closely as possible. So based on these different views, we have like a different definition for the AGI. And then in terms of like the timeline of when we actually can achieve the AGI, there are like a different debates. So some people are claiming that AGI is already here. Some people say that it's like near future. Some people are thinking that it's just going to be after 2040. And some people here are skeptical, and they said we're not going to achieve AGI at all. And the main reason that those skeptical perspective, there are like for me main areas that they are actually just have as a reason that we can be a skeptic about AGI. So we have like these fundamental limitation. So some people believe that current AI approach, there is some level of barrier in front of them. So as you may heard from some of these news and updates, that some of these models, the accuracy is not growing as we scale the compute and as we come up with the like a new architecture. So that's kind of like a limitation that some of the people raise. Also, some people say that there are like some missing pieces, some component that we don't have, like things like around the proper reasoning, proper consciousness. These are like the key areas that they cover as the main reason that they are skeptic about AGI. But the thing is, to design an AGI, so we have like different approaches. So we have this concept of symbolic AI, which in there, it is more like a kind of classic AI. We use just logic and rules to build the AI solution. But then plus that symbolic, we have things like neural network, all those deep learning approaches, and also some of these cognitive architecture. So these three main, I would say, approaches, if they combine together, that's where actually just the real AGI can I would say, achieve. And then there are like different learnings that can help to accelerate the development of AGI. So Amin already covered with some of these learning, like reinforcement learning, unsupervised learning, transfer learning. And then there's another key, I would say, element of learning that we name it as a meta learning, which is more around how to learn a new skill, how to be good at new tasks. And that's a very fundamental for achieving the AGI, because we need to have an intelligence that can learn. So if there is like a kind of unknown situation, that AGI should be able to learn that. And that's another, I would say, key learning mechanism that need to be there so that we can just start to have that AGI in place. In terms of like the key capabilities that is needed for the AGI, so there's like these reasoning capability, and if you're following these different LLMs and those reasoning model, we can start to see that those large language model and those AI solutions start to have good level of reasoning. The next capability that is needed is more around the emotional intelligence, so more around like the AI to be able to recognize and also respond to the human emotion. Adaptability is another key capabilities to make sure like that AGI or that AI solution can learn and apply knowledge. Creativity is more around like how the AI can think and also add new valuable idea and a solution. And then continuously improvement through the self improvement mechanism, that's another key capability. So if we wanted to claim that we have AGI, we need to make sure these 5 main capabilities is there so that we can claim that AGI, we are actually just achieving AGI. So if you're again following some of these updates and news, we will see some level of improvement in each of these capabilities, but we're still not, I would say, quite there. And then we need some more time, I would say, to make sure that we have that AI that can be claimed to be AGI. All right, so we already covered the AI infrastructure, AGI. The last topic that I'm going to cover is more around the AI governance. And then Amin already covered some of those topics around AI for goods, which is more around how we can use AI more responsibly. So AI governance is actually, the topic is there to enable that. So to enable trust for the customers, for the key stakeholders that who are actually using those AI solution. Also for companies and businesses, AI governance enable the brand reputation. So any of those risks that can be enabled by those AI solution, it can have a huge, I would say, impact on the brand reputation. And AI governance is there to enable and protect the brand from any of those risks. And also, at the same time, we started to see more policies and regulatories that are pushing for responsible use of AI. And that this AI governance is there to enable all these 4 key domains, and to help businesses reduce the risk of AI solution. So currently, if you check, we started to have a number of frameworks, which is more like a kind of like a document that explain what needs to be done in order to make sure that AI is used in a proper and responsible manner. So we have like some voluntary frameworks like NIST, ISO, IEEE. They actually just publish some of these frameworks for AI governance. And also at the same time, we started to see in some countries in US, in Europe, like we have like EU AI Act that start to be mandatory for some of these businesses. So those are also some of the frameworks that are there to enable better and more, I would say, responsible use of AI. So if you are interested in domain of AI governance, I would definitely suggest to check some of these frameworks that can help you better understand what are the key areas and topics. But then in nutshell, these are like the 5 main principles and domains of AI governance. So in AI governance, transparency is one of the key areas. We need to have like a proper, transparent and explainable AI system. So if, let's say, we are using AI for, let's say if a bank is using AI for loan approval. So we need to have a transparent and proper reason of if that AI solution approve or reject a loan. So that transparency is needed there. Also, the ethic is another key domain. So we need to make sure like the AI is actually whatever is actually generating is aligned with the human value and social norms. Accountability is the 3rd domain, which is more around like the responsibility and also ownership. So that if AI reach to a specific outcome or result, we need to have like those individuals or even like processes accountable for that. Fairness is another domain, which is more around like avoiding bias and ensuring that there is a equitable treatment for different genders, for different, I would say, demography and all those things. And the last but not least is more around like safety, which is more around making sure that there is no harms and also ensure the reliable operation of the AI solution. So these are like the 4 key domains of AI governance. And then whatever that we're seeing, like especially a lot of businesses that they want to incorporate those AI governance rules, controls, and policies, one of the key, I would say, focus is just to make sure like those AI governance frameworks and also policies can be incorporated with the existing governance. So if you are if you ever work in this space with the businesses and companies, they usually have like their own IT governance, corporate governance, and also data governance. Those are like the 3 other areas which is very well known for the businesses. And AI governance, which is, I would say, more like a kind of emerging topic, in order to be successful, it needs to be integrated with the other 3 main governance, I would say, frameworks within the organization. And one of the key, I would say, topic when it comes to the governance is about the risk. So when we apply AI governance, the main reason is to just reduce the risk to the organization. And we need to make sure like the risk of those AI solutions are at minimum for the businesses. And then in order to have a better understanding of how to apply those treatment and making sure the risk is at minimum level, there are like 4 main types of risk classification. So like, let's say if we have like an AI solution and we wanted to see what is the risk for that specific AI solution, there are like a number of different ways, like impact-based, which is actually just EU AI Act, which is one of those framework for AI governance that is used. Is just check the impact of the AI solution of different stakeholders, and then based on that impact, decide what would be the risk relevant to that AI solution. So let's say we have like a unacceptable, high, limited, and minimal, which is these are like the classification of the risk based on EU AI Act. And as I said, they have like a specific definition when they say this AI solution have a high risk. They have like what sort of AI solution go under that category, and then they provide some treatment and also provide recommendation of how businesses can deal with those types of AI solution when it comes to risk management. We also have like autonomy based. Let's say if AI is more like used as an agent, and it's an autonomous agent, so it can have a higher risk compared to a chatbot, which is just more like a kind of assistant. So based on the autonomy that AI provide, it actually tagged and provide what sort of risk is associated with that. And then the third approach is more domain-based, like some of these sectors like healthcare, finance, they are very, I would say, sensitive sector. And then those domain, the risk associated with them can be like for the AI can be higher compared to those the other domain. And then based on that sector, the AI solution have a different, I would say, risk level. And also the last but not least is trustworthiness, which is like specific to one of these framework named NIST AI RMF. So if you go to the framework, it actually just categorize the risk of AI solution based on the trustworthiness. So one of the key, I would say, tools, some of the key tools that can enable, I would say, better governance, especially when it comes to the AI, we have model card, so that can show the type of data that is used for the model, the data that is used for training the model, and also the impact. So these are like the 3 main tools that can enable more transparency for the AI tools and can enable, I would say, more responsible way of using AI. So any businesses or any company who is developing AI solution, they need to have some level of solution for these 3 areas. If they have a model, they need to have a model card providing all those documentation of the characteristics of the model, the limitation. They should have a data sheet of how actually those model, what sort of data is used, and provide the documentation for those data set. And also they should have the impact assessment. So for this specific AI solution, what would be the impact on different stakeholders, and if providing some level of recommendation in terms of to making sure that those risks are reduced to those stakeholders. So these are like the three, I would say, key tools that can enable more and better transparency for AI solution. And as things go along, because like AI solution is not one-off solution, so they need to continuously improve. They need to even like sometimes retrain with the new data, and then there should be some level of regular audit, continuous monitoring, and these are like kind of like every organization that using those AI solutions, they need to have some mechanism in place to make sure that they regularly audit their AI solution, and if there is any new risk associated with those, they can identify and remediate as soon as possible. So these four, I would say, key areas enable ongoing monitoring and enable, I would say, a more effective AI governance to make sure that the risk for those AI solutions, because they are continuously updated, those risks actually are at the minimum level. And the last but not least is more around the concept of MLOps. So, like when you want to operationalize any solution, especially when it comes to the AI ML, there is like these different process. Like for software engineering, we have these DevOps that operationalize the software for the organization. For AI ML, we have this concept of MLOps, which is talking about how to develop a solution, how to test it, how to deploy that solution, and how to monitor that AI solution. So governance play a key role across all these four phases of MLOps. So in development, making sure that those governance policies and rules are applied is the key. When it comes to the testing, making sure like the governance requirements are tested for the AI solution is also important to make sure if there is any risk, it can be identified as soon as possible. And then when it comes to the deployment, let's say a new version of the AI solution is going to be deployed, making sure that we have a controlled release of that solution is another key areas to make sure like that AI is actually developed and also deployed in effective and also a responsible manner. And finally, the monitoring, which is like any other technology and any other solution, making sure that we have a continuous oversight of the production for the model and the AI solution. It actually just helps to make sure if there is any risk or any challenges or issue, it can be identified quickly, and then it can be resolved as soon as possible. So these are like the role of that MLOps that can help to have a better AI governance in place. So in key takeaway from those slides, so we covered those AI infrastructure from classic compute power to accelerated compute, which is the foundation of AI infrastructure. We covered those key players in that space and what's happening in the market. We also cover how a small language model is actually disrupting the AI infrastructure market and how it actually impacts. We also cover the AGI and those key capabilities to enable AGI. And then we also cover the AI governance, all those different frameworks that can help to use AI in more responsible and effective way. So that's all for my presentation.